I have this problem. A single die is rolled twice. Well, let me say about this. If you roll one die twice, that is the same, I'll just say is the same as rolling two separate dice. Two separate, well, I can't spell today. Two separate die. I guess I'll write dice. Dice is plural for dice. For die, I'll put dice. I think the English isn't quite right there. So you English majors, put it correct in your notes. So anyway, here I like to think of it as two separate dies. And then I can say stuff like, well, here I got this one, this die within a die, and there's my two. I'll call one of them, the first roll I'll call the yellow big die, and the second one the inside white die. And if I did just one and I rolled it twice, it's the same mathematically. So I have this, and they have listed here the entire sample space. Because look what could happen. I'm going to actually do like blank blank. So the big die, the yellow die, and then the white die. The yellow one could land 6 different ways. And the white one can land what? 6 different ways. 6 times 6 is 36. Now, if you're playing a game of chance, you're probably not thinking about the 2 dice with, if one of them lands, I'll use these now because I can manipulate them. If one of them lands on a 5 and the other one's on a 6, in the game of chance, that would be the same as one on a 6 and the other on a 5. But mathematically, those are 2 different outcomes. And so on my little chart here, I'll go back to my single die here. My yellow die, this is all the things that could happen, 1, 2, 3, 4, 5, 6. This would be the yellow on a 6, and this one would be the white on a 5, and it would be 6, 5. Now, if it flips, and the yellow is on a 5, and the white is on a 6, you have 5, 6. They both sum up to 11, but mathematically, you have to count each of those outcomes. So, let's read the question again. The set of 36 equally likely outcomes is shown to the right. The first number in this case shows, I may have said it backwards a minute ago. The first number shows what's happening on the yellow. I think I said it correct. And the second number shows what's happening on the white. The question here is, what is the probability of getting an odd number on the first one, which I've called the yellow, and the second one, which is the white one, an even number? So odd on the first, even on the second. This is the first. Odd is your 1. Let's mark them like this. Odd would be, the first one is a 1, or a 3, or a 5. Now, an even on the second would be, the second is a 2, the second one is a 4, or the second one is a 6. They want both, so we want where they overlap. I'll circle them in red, so we'll take 1, 2, 3, 3, 2, 5, 2. We'll take 1, 4, 3, 4, 5, 4. We'll take 1, 6, 3, 6, 5, 6. Not this guy. I use that for another example. So there are 9 possibilities. The probability is 9 over 36, and that'll reduce to 1/4. Okay, let's look at number 29. A single die is rolled twice. Well, that's the same as rolling 2 different ones. So let's see though, it says it's rolled twice. Find the probability of getting a sum of 2. Let me go back to my 2 that I can cheat with this. If it's a 2, what's going to happen? 1 and 1. I'd have to get 1 on each. And if I look at my little chart, there's only one way that can happen. So the probability of getting a sum of 2 is 1 over 36. I'm going to make up another problem because you're going to get all kinds of sums right here. How about a sum of 6? So if I look at my chart, I'll put this with my orange marker, a sum of 6. If I look at my chart, that would be 5 plus 1, 4 plus 2, 3 plus 3, 2 plus 4, and 1 plus 5. Sometimes students will say this, aren't there 6 ways to get 6? Yeah, 5 plus 1 is 6, and 1 plus 5 is 6. So let's see, here's my 5 plus 1. Now I'm ignoring the little white die in the middle. 5 plus 1, and then 1 plus 5. There it is. And then they'll say, well, don't you have to count 3 plus 3 twice? Do I? Here's a 3 on the yellow and a 3 on the purple. 3 plus 3 is 6. Now look, I'm going to say this twice. You tell me if I had to change anything. A 3 on the yellow and a 3 on the purple is 6. Do I have to count a 3 on the purple and a 3 on the yellow? No, they're the exact same thing. We've already counted that. So if there's a double, you'd only count that one once. So look, if I look at a sum of 6, 1, 2, 3, 4, 5, the probability is 5 over 36.